Welcome, part 17 of our little printer build here. We basically continue where we left off last week, which basically means we redid the bat, but there were like some problems with the parts I redesigned. So we basically will replace most of these parts again. You can check if everything is like up and running. Looks excellent according to YouTube. Cool. Yeah, so we'll basically replace a couple more parts here around the bat. I also printed longer versions of the servo arms that we used for the Klicky probe. So these are like 1 centimeter longer than the ones we have at the moment. So it should basically just raise the probe up a tiny bit higher. So we don't have the issue that like the switch collides with the bat if you move over. Um, so yeah, lots of parts. And I actually see like I only there's the other one. So the biggest change of these parts, besides like some alignment issues and bug fixes, is basically that we also now have the bushings in the back. So far we only had them on the front parts here, left and right. And in the back it was basically like floating in a certain sense. And I hope this would be good enough, but if I push here, you can see that like everything shifts a tiny bit. So there was also something like somebody pointed out last stream. So there can be a bit of sway, like at least like if the printer is moving quite a bit, like there can be like a bit of sway, which will cause misalignments in the layers, of course. So that's not good. We don't want that. So this is the new part. And basically you can see, we also will need to rework the cabling here a bit. So yeah, so this has to go. But basically the new part here is tiny bit longer and has this extension here on the end where we basically just clip in this bushing. It's not super important that this is like super fixed in the Y direction. So this is really just like clipped in. The only important part is that this prevents the bat from moving like in this direction, basically. So if it moves a bit in this direction, it's fine. I didn't want to like over constrain it, so this has like, it can move a bit. So in case these are the 4 like rods we have vertically are not 1000% aligned, it should still be kind of okay. So yeah, that's kind of like what we're going to do today. So I have all the parts ready. And then the question is if we, I guess first we have to do our heat set inserts again, as always. And I guess we just take the part. We will, yeah, we will need to redo the bed wiring. Let's see how we do that. Yeah, and then off we go. I would say enough talk for the beginning. I was just wondering, do we take it apart and transfer the heat set inserts, or yeah, let's just take fresh ones again. I still have this whole bag with like old parts that I still have to take apart and recycle. So I guess we can just add them here. And my to-do list got a tiny bit longer. Cool. Let me just get ready. Also didn't plug in my soldering iron yet. $400 is maybe a tad too much. So I also actually didn't clean up the parts. I actually started printing like most ABS parts with these little like mouse ears, which is like a new setting in Orca. Like new is relative, like it's from Orca 2.1, like not the new latest version, but the previous. It's basically a type of brim, but it just like adds it automatically to any sharp corner. So like any sharp corner that's like really prone to lifting off the bat just adds these little like mouse ears, and like they print super fast. They don't need like a lot of material. And what the coolest part is actually about them is like they're really easy to clean up. So normally like the brim is like always a bit of hassle to remove. And you always have like some leftovers on the printed parts, but like the mouse ears are really easy. Let's actually just quickly remove them from all parts. Yeah, I was like barely home this week because I was quite busy with work and had some travel time to different cities. So I was just like printing these parts like in the evening quickly, pulled them off the bat, printed the next batch. This one actually has like a bit of like elephant's foot. Not sure what happened there. Like these parts are really big actually. Like I think these are the biggest printed parts. Oh no, that's actually a lie. Oh no, they might be the biggest parts on the machine actually to be printed. So basically, oh yeah, I also stopped printing these in the turquoise ABS because I was just running out of it slowly. Like I have a bit left, but not too much. So like these parts are now all black. But yeah, these two basically are just like filling one V0 bed basically. Yeah, here it is actually also support. Might be smart to remove that. Yeah, like some of the parts have a bit of elephant foot. And you pay attention, like when we put it together, that is not a problem. Not sure if something changed with my pad or something. And last part. Let's remove the support right away. Okay, that looks to be it. Then let's go to step 2, heat set inserts. Let's quickly collect all the chaos. I wonder whether we should do like one corner by one corner, just like do the heatset and install it and do it one by one. Yeah, maybe that's a good idea. Let's just start with the corner here on the front right. I don't think we need like too many heatset inserts for this one actually. I think that's already it. Like we only need 4 on these. I can also quickly explain like the change of this part actually. Let's grab the printer. Maybe let's first remove the bed, then we can work. So that's something we have the pleasure of re-leveling later. Here we go. Now we should just be able to lift it out. Oh, we have the we have these little zip ties in the back here again. Totally forgot about these. So basically we have these end stops here, left and right. And actually also want to get rid of these. So if we now reinstall it, we are not gonna install these end stops. Okay, well, I didn't quite get a good angle with my cutters, but just broke off while pushing it, so it's also good. Here we go. So with this, we should be able to just... Oh, we also need to unplug it maybe. That would be a good step. Oh, and I now realize we even have more cables here. So there's also the servo here in front now that we installed last week. And that now also ties into this cable chain here. Oh, let's unplug that. And get the cable out of here as well. Yay, now we can finally free the bed. Okay. Cool. And these were a little bit tight, the holes here. Collecting all the hardware. Okay, cool. Let's take a look at this corner here. So basically, yeah, you see like we replace these turquoise parts here. Let me see, get a good angle on that. So we replace these turquoise parts here. And the main difference between the old one and the new one is basically, you see, like here we have way more material. The problem was basically in the last stream, we had basically had the shape like this, which also was not super ideal because like it was a little bit like thin here, but good enough. The main problem was I totally forgot about the belt, so I didn't model the belt in my Fusion. So basically the corner was like here and the belt kind of went through the part. So that obviously did not work. So this is a new version of it, and you see basically I just like straighten it out, and now we have like a cutout here for the belt, and I hope that it's in the right spot. So the belt just runs through there, and the rest of the part is basically the same. I don't think I changed anything else. So let's tackle that right away. Let's also remove the tension from the belt. And the screws here in front were really tough to get in. So not quite sure why that was the case, but now they're also tough to get out. Maybe let's check if the heatsink inserts were properly aligned. Yeah, they're not super straight. I think that's just the simple cause of that. Okay, and that's like the inner parts of this. So basically these two rods are just like clamped in here. And that's the bushing that kind of like secures everything in XY. And here in front we have the tension mechanism. So basically the screw, the bottom belt is clamped in here in this little slot, and the screw just pulls it up to tension. So let's just, actually let's just unclip this on the back, and then everything falls apart. And then we should be able to disassemble that. Okay, let's put in the new part. Oh, wait, first I have to put in the belt. First the belt. And there's like this little window in the back where we put it through. And this just goes in here. And oh, the old part still has the screws. And this goes to the recycling bin. Here we go. So this is our tension mechanism. And now we can put the cover on. I'm not fully tightening those yet. That's something we can do later. And let's see if our like screws in the front have an easier time. No, so like something is off there. Poor screws. It looks super lined for me. Like if I just look into the front, like no, the bottom one is also fine. Okay, and let's make sure that the belts are okay. Oh, we need to retension the belts, of course, later. Oh yeah, we now have to put that through the hole. Oh, that might be too small. And then above, around the idle on top. Oh, yeah. I think it will work, but like it's in the right spot. That's a good thing. But like a bit more clearance wouldn't have hurt. It actually doesn't touch anywhere, so it's kind of fine. But for next version of this part, definitely like let's just add like 2 mm more of clearance around it. Okay, I'll move this one tooth up that we have a little bit less tension on the belt for now. And then we can use the tension screw on the front to tension this later on. And there's actually like quite a lot of travel we can tension. So we have all the best chances to get this like equally tensioned on all four sides. Okay. So that's this part. How about we do the back side on this side as well? Then we kind of have this out of the way. Yeah, you already see like this is like super far to the front. So what we did here with the teeth is not correct. Yeah, it doesn't really matter because we take this now apart as well. That's something we need to fix. Two more screws here in the back. Oh, I think. So either people are really quiet today or I have the wrong chat. I have the wrong chat. Hi, Big City Tours. Hi, Smolder. Hi, Zemgod. And hi, Om. Let me fix that. I have no clue what chat I looked at. Let me quickly fix that. This goes there. Yay, here we go. Hi guys. Um Yeah, I have no clue what stream I looked at the chat. Because I had an active chat. It was just like nobody in there. Well, okay. Problem solved. Back to this. Oh yeah, we now have, of course, two more screws here in the back holding this also together. And then this should just fall apart, basically. It literally falls apart. That's what we wanted. Let's get the tension off here. Okay. Let's also get the belt out of this. So it's the exact same tension mechanism, front and back. Yeah, and here we had this like end stop switch, but I'll try to get rid of this one. So we don't install this on the new part. Oh, then the other thing we need to take care of here is these cables, we need to route them differently because we now need this rod. And while I say that, I now realize we actually have a bigger problem or a challenge at hand. We need to put that on there. I did not think about that. How do we do that? Okay. How do we do that? Yeah, I think we have to, let's see, if we loosen the screws here, if we can, I mean, we at least also have to loosen them on the front. I mean, we might need to work on this, yeah, like this way it comes out. Let me also do it on the front. Front is not as easy. Front is, oh, because we have the belt holds it down. No, it's also free. Let me see how we can do that. So the black part here in the back is one part. So we can remove this. And then we can kind of like bend. Let's do it like this. I most likely already screwed it up now. But let's remove the thing here on the back. Okay, collect the screws for the bed. Already lost one somewhere. Also, like this is like a little bit like tangled, so let me untangle that. Oh, there's the screw on the magnet. And let's just really remove the whole corner here. So I'm a bit concerned about like just like the whole squareness of the frame. That's still something we need to do. We never like fully like took the time to square out the frame. And with this like building or way of building, it's a bit challenging to do so. But actually the new bed will help us a lot because we can basically copy the distance of the two rods from top to bottom. So it will definitely help. Is there something else? solid, or is it just the screws not being? I think it's just the screws not being fully out. Yeah. Do you use too many screws on this build? Potentially. Here we go. Yeah, and this is actually printed like this. So it's like just like printed in a V shape, which gives it actually quite good like strength in the vertical direction, but also like in this. Okay, so yeah, we can squeeze it on. Here we go. Okay, it was easier than I thought. Could have been worse. Could have been worse. Yeah, but basically, so at the moment, I'm just trying to like improve like all the parts we have so far. So I assume like I mean here we need to like cut. I heard some plastic cracking sound. It's not very confidence inspiring. Yeah, here we need to like why is this cracking? I mean I don't see any cracks, but it's like just like making sounds which I don't like. Okay, it looks fine. Let's not touch it. But it's also like back where it belongs. So I'm just like trying to fix like all the small issues we have. And then step by step just like fix the overall print quality issues. So I think for now, like the one main problem we still had that like the bed was a little bit wiggling. And this is the fix for that. So you see now here the ah, I have to move that rods in here. It might just be a bit too long, so maybe I have to open the front again. Like do first the back and then the front. I think that's the order to do it. Oh, well. But yeah, so basically this part, it also is like now locked here on the back. The old part was not, it was missing that like that bushing at the back. Just like the back part here was missing. And it should like give everything a bit more strength. The reason why I didn't want to do that initially was that if you do this and you have like the bushings on all four corners, like the rods for the verticals need to be super parallel, otherwise you will have binding. So yeah, I just want to get around that issue. But seemingly it's required. So, oh, seriously? Okay, I have to fully undo the front. Okay, the other side, let's do the back first. We have to do the first back, then front. Okay, so we put this on here. Oh, so it's like there's like really little overlap here in the front. So let me just pull it out a bit on the back that we have more more in the front. That's like all the parts are designed in a way that the absolute length of these rods doesn't really matter too much. It's all like quite flexible because I cut these rods by hand and not with a miter saw. Hi there, T. You need a third hand. I think many of us need that in many situations in your life. That would be really handy. Yeah, but this is like here, like this wiggle we had here on the back, completely gone. So that definitely is a good improvement. T, was it you who suggested that last stream? Like somebody suggested like to add like this bushing on the back last stream. Oh, that was you. Cool. Here it is. So let me show you a close-up in a second. So what I did, you also suggested bed mounts, yeah. And I thought about that, and then I decided that would be like a good improvement for later, because I didn't have too much time to spend to work on the parts, because I was a bit on a tight timeline this week. So I left the bed mounts in place, but I still think it's a really good suggestion. So what I did here basically is I left it open on the back. So if these rods are a little bit like this, the bushing can adjust itself because like the it's otherwise would be like over constrained, right? Like the front one basically should just define the position, and all this is doing is like it's preventing this like rocking motion on the back. Like once it's properly like structured, like put in, this should be fine. So this is the same that we also have on the Y. Actually, it's the same mechanism, but just like it's allows for like some adjustment. But yeah, there was actually like not even a lot of stuff to add. I don't know why I didn't do it. Like I know why I didn't want to have it like over constrained, but I think this is a really important improvement. Let's just put this together. Oh, we need to add the heat sensors here. It's more that it doesn't wobble left to right. Yeah, exactly. This will 100% prevent the left-right wobble. Actually, I was looking at some prints I did with this machine. I printed some boron cubes. Let me quickly do the heatset inserts and I'll show you the prints. And I think there are some artifacts that might have been the wobble. Yes, now it's really like it's printing in general. It's just like not printing super well yet. But yeah, it's just like improving the parts now to eliminate these issues step by step. Okay, I think I have it over here. Yeah, here. So this like hollow boron cube I printed on this machine like not too long ago. So it's basically like the hardware configuration with the bed we had. It was still an old bed, but yeah, it doesn't really matter. And on X, it kind of looks fine. Like there's a bit of ringing here. Like yeah, it's a bit hard to see with this color. But overall, X looks okay. But on Y, you see like a really weird pattern. Let me see if I can like. I should like get different filament for testing on stream. Yeah, I see it here a bit. Like A, there's like uneven like layers, but I think that's a different issue. There's also like a little bit of like a wobble to it. And this wobble is like everywhere. It's on the entire front. And given that this is Y, this would be the direction where like this like bad wobble would show up. So I think maybe here you can see like there's just like the surface isn't smooth. I'm not quite sure how to describe it. It looks really weird. It's not like the layers are inconsistent. I think it's just like, yeah, I'm shifting a bit. So hopefully that would be fixed. Yeah, and on X, it's a little bit, but not too much. Like it's way more ripple is a good word. Yeah, like ripple. It's not ringing, it's ripples because it's just like completely consistent from left to right. Where did I put the screws? Why? Oh, that's too short. Where did I put the other screws? So these are short ones. I think the short ones might go. No, also here I need long ones. Ah, get out. Where did I put the long screws? It's a mystery. Let's use new ones. Do you have a board suggestion under $40? Um, you can go with a SKR Pico. That is pretty cheap. Yeah, SKR Pico would be one suggestion. And then also like the Mellow Fly I use here, like the super small one, that's also like very cheap. Mellow Fly Micro 4. This one is actually quite cool because it has a CAN bus adapter on board. Let's trash the trash. Here we go. There are two more screws here on the front. A bit awkward to show you because of the bed flying around back there. It's also very smart. Yeah. I should remove them actually. Like they are not required at all. Like actually we can also just leave them out. Oh no. Ah. Okay, let's leave them out. We forgot the heatset inserts here. There were heatset inserts we were supposed to put in, which we did not. So the short screws were for here. But yeah, it's not required at all. Like this part doesn't need these screws anymore. Oh, but this is a problem. What happened here? It seems like we pulled out the heatset insert from the material. That's inconvenient. And if I was thinking to get a PDT Octopus, I have no clue about these boards, to be honest. I never needed a board with this many steppers. Let's see. Yeah, we just pulled out the heat insert a bit. That's not confidence inspiring. Let's try this again. I'm not sure why this would be the case. Like, we never had issues with this. That's pretty odd. But while we are at it, then I can't get this part out, but let's just install the heatset inserts like this. I always try to design my parts where heatset inserts are melted into the back. Yeah, that's also what I do often because it's just way stronger. It's just like for these parts, like quite awkward to do. And usually it works. Like I did it this way, like on all the, not all, but most of these parts, and it works. So it's not like horrible. But yeah, you mean like oh, can show like this here, where basically a screw comes from this side, and then like you have to heatset insert from the back. Yeah, it's way stronger. There's no discussion. um, it just makes it harder to design the part. Okay, let's try this again. Let's also start with the short ones here, maybe. Yeah, exactly. Yeah, it's like I have it on many parts. Yeah, it's just like makes it like way more difficult to design certain parts. And I feel like my part design is already quite difficult because of the round rods. Like I feel like with like normal aluminum extrusions, it would be way easier to design parts. But what I also found is like usually before you pull the heatset inserts out, the parts start to split if you don't print them in the right orientation. So I also pay like way more attention to the print orientation actually. Does it happen again? Let's not over tighten these now. Yeah, it happens again, right? Yeah. I don't know what's wrong here. This is super weird. I don't think it's like a big impact on stability, to be honest. So something is wrong with this part here. Don't ask me what's up there. The underside is also fine. It's really just the top one here that has some issue. Let's leave it like this. I don't think we can do anything for now to fix that. Can I use acrylic for the printed assembly? I don't own a 3D printer. I'm not quite sure on. Acrylic might melt, but I don't know at which temperature. Best to research that. Okay, let's apply all the lessons learned for this side. I don't do the belts yet. Let's do the belts all in one go at the end. So for this side, let's remove the bottom parts. Need to hold the soldering iron longer to plastic so it melts around the insert. Less pressure along the heat time. Yeah. I'm just, like they're all fine. Like these are all the same. It's just like this one. I don't know what this one has for issue. I mean, we can take it apart again, but I feel also like now because it pulled out twice already, it's kind of like a lost cause. Hi there, Steve. But on for acrylic, like technically it only needs to survive like a couple prints, right? Because you can print the tool head mount with the printer. You can also maybe check if you, for temporary setup, because it really doesn't need to have like a lot, right? It just, not sure if you use linear rails or something. Technically, it can also just be like a piece of plywood that you just drill to the mounting holes of the linear rail, and then mount the hot end to it. I mean, it's good enough, right? You only need to produce like a couple of parts, and those parts don't have to be pretty, they just have to be functional. So you can just work your way up in a certain sense. And you just like the first iteration is just like plywood. And then the second iteration is like a basic printed one. And then you can just like, go more fancy from there. I'm using linear rails. Yeah, they should be relatively easy to, just like flash mount like a piece of plywood. Drill two holes in the plywood and mount the hot end to that. And just work your way up in a certain sense. Just like get it printing. And when it's printing, you can print like a basic mount, and then as the print quality goes up, you can have like more sophisticated solutions. Yeah, I still installed these parts the wrong way. Like this was supposed to be on the bottom. Like this was supposed to be the mount for like for a foot. But yeah, it's like too much work to flip that. So I now have these like glued little rubber feet on the bottom. That works for now. Okay, let's take this apart and then let's put the heatsink inserts in for the new part. And let's make sure to actually like, let me put it a little bit higher because right now I have it on 277. I think usually I had it more on like 290, 300. Maybe that's the reason why the heatsink insert isn't as strong. You're doing a test. You're doing a test print on stream. Yeah, it depends a bit on time. Like depending on how long we need to take this apart and put together. We can. The other thing I want to do, like we need to change the homing. So that's something we need to do before we can do a test print, obviously. We need to fix the homing. Oh, sorry, that's like horribly focused. But yeah, would be my goal to print like one of these hollow Voron cubes. They print pretty quick. There we go. 2 parts for the recycling bin. Recycling bag in this case. Okay, yeah, let's heat set insert some stuff. So we need this part. This is also recycling bin, including the end stop switch. And these two need some heatset inserts. If you're putting heatset inserts, try a little super glue it till you can print another part. Yeah, I think it's not super critical. Let me quickly do the heatset inserts and show you. So basically it's the bottom one is still fine and it's only the left-right connection, which we actually don't need anymore. Now that I think about it. No, I think we can actually just leave it out. It has no purpose anymore. It would actually also simplify the part if we just leave this out. I'll give them all like a little bit extra. And let's not forget these two again. Yeah, so basically it's only for this like connection piece here, which if I quickly add this here. So this goes from left to right here, right? And I don't think we need them anymore, to be honest. Because now we have these bushings left and right. So I don't think we need this because like the vertical is defined by the belts. And even without this, like this completely, like this is rigid. Like you don't need this. What do you think, Stephen T? Do I need those? I think we can remove them. Like it's really just like this like left-right connection here. I would just kick it out. Then we don't care about that. And like the next iteration of the part, I can just like make it a tiny bit smaller. I think you should have it. Okay. Let's leave it. But I don't think like I don't see like anything this would restrain or like make more stable. Yeah, it's definitely stiffer. Like if you have it, it's stiffer. The downside, actually, like it might be like a bit of like an upside if you don't have it, because if your motors get desynced for whatever reason, there's no like the two sides can move more or less independently. You would design it differently though. Tell me. My print bed size is 180 by 180. Although, to be fair, it might be more like 175 by 175 because I think there's some issues around the edges with like reachability. I would make 4 pillow blocks to each linear rod. Then make a bed frame that bolts. One second, let me show you something. Ah, okay, I dropped one, but didn't see where it went. So what we had before was this, basically from left to right, like this. And basically the bed was mounted to these. And that works. It's just a bit awkward, because like you get like a lot of rotational forces. So it's way better to mount to the corners. But technically you can add these as like extra strengthening parts. So like nothing's stopping you from putting these in. Maybe we will put them in at the end again. But it's basically what you meant, right? Like to have like from left to right these connections. But imagine 4 pillar blocks that hold linear bearings and belts. Then a square frame that mounts to each pillar block. Yeah, well, that's basically what I have, right? The only thing that's missing is the front connection. Because like we have 4 blocks on each corner, right? I mean, the rear ones are a bit oddly designed in that way. That's a War on 2. Why is it a War on 2 then, Steve? I mean, the bed would still move up, right? So it's not technically a War on 2. Yeah, this one goes to the recycle bin. Also here, let's pull these a bit more to the front. Oh, there's a bit of friction on the screw. Let me quickly double check the heat sets inserts if they're straight. Let me quickly recenter them. I think they're not super straight. Holding the bearings and then belts, then square frame that mounts to each per block. Yeah, so you really basically just mean that like on each side, like we have a connection. It's kind of what we have. It's really like we're missing the front one. But yeah, you can really just also have like on the sides here, like just like mounts for the bed. That's also possible, right? The big benefit I had with this setup here is like it's completely modular as well, because like you can mount any bed with this, right? You can like completely like adjust where the bed mounts are, whether you have two, 4 or 3. Then it's a quick disconnect for the bed mounts. Yeah, yeah. It's just it's modular for sure. It just didn't work super well when we had it. I mean, mostly it was just like not well designed because the bed was sitting too low. Technically, we can still opt for that later on, right? Like you don't have to use these bed mounts. We can just cut them off basically again and then add these center pieces back. That's always an option. Right, I want to double check that these are straight. Which they should be. Yeah, it still doesn't go in very smooth. I don't know. I think I have a bad heatset insert karma today. Yeah, that's okay. Two short ones from the front. Huh. The front ones are now easy. They were like misaligned before. Okay. Let's do the belts in a second. Let's first get it like all together. Do have to get rid of this part though. Use the 4 pillow brackets you do now, then add one rod either side to make it modular again. For any bed mount, I guess. Hi there, Tinga. Yeah, I mean, we can always do that, right? Like it's just like then to remove these corners here we added. And then we can also remove the rod in the back. I mean, technically, it's possible. It wouldn't be like on the top of my to-do list right now, to be honest, because it's not adding any technical improvements, so to say. Because right now I would focus on like making it print nice, and it's like also like the detachable corners. What he suggested is a great suggestion, but it's not quite what I would focus on right now. Like I really first want to have a machine that works well, and then also like initially the idea was that you can scale this machine up or down, where the modular bed is super important then, right? But basically my idea was to have this machine in 3 sizes, that you have it as a V0 size with 120 bed, like this one is a middle size with the Prusa mini bed, and then like a larger one with the Ender 3 bed. Let's see if this heatset insert also gives us trouble. Nope, this one seems to be fine. Maybe it's just like the part bed or something, I don't know. Yeah, and these screws, like, I can also remove in the next iteration. They're like absolutely pointless. Cool. So that's technically our belt. Like, doesn't really work well if you don't pull on all four corners at the same time. But we can add the four corner pulling now. So let's just do the belts one by one. I quickly need to check. Yeah, this one is the right one. I feel like they're a little bit different front to back. I didn't, yeah, like the dimensions are ever so slightly different of these like blocks. It's maybe also something I can improve. Oof. Okay, we have tons of belts flying around here. Let's see if we can get them back in order. Let's also, because now they're all loose, except for this one. Let's also just align this on the top and then like do the belts. Because this can like dock everywhere. On the top, then we have like a little bit like of a alignment helper. Yep. I mean, just actually pull the belt out, do it all from scratch. So this goes over the idler here on top. Then it goes under the pulley here. Okay, maybe it wasn't as smart idea to fully pull it out. And we go around. Now the third hand would come in handy again. Around the pulley. Then back up. So that's our belt path. Now we need to go through that little hole here. Very quickly. Maybe we have to like give it a little bit more belt here on top. Oh, I know why this is. Ah, shit. It needs to go through the hole here now. So it needs to go over there. Still give this like a tooth more. And then this goes through here. Now we're talking. And then it's going to go in. I would have been smart enough to put in the screw here first. Then we can tension it. Hmm. I think I need an Allen key for that. Like this one is also still something I have to do. This needs to move to the top part, like from the bottom to the top. A, would it make it way easier to align this? But B is also like it's really easy to pinch your fingers here when the bed is in place. Like it's really easy to pinch your fingers, and I say it every stream. I totally see myself doing that. Okay, similarly. Now was too many teeth. Here we go. Now we can tighten that or tension that in a second to the target, and then this should be fine. Okay, that was a bit awkward. Let's do this again. Yeah, another thing we need to do is that's like a learning, because we have like two different belts on one motor here. Whenever you tension one, you need to like undo one of the pulleys. Oh, it's already okay. And yeah, like technically we should add thread locker here as well. The only bad thing about it being connected at each corner would be that no way any kind of Z tilt it will bind. Yeah, so technically there's quite a lot of flex still in the system, so you can have some Z tilt. Because it's not super like at least at the moment it's not super hyper rigid. Also with the old parts with the two rods, like you can always like if they're on top of each other, they can always like move a little bit out to give like the flex up or down. So theoretically it binds, but practically because it's not hyper stiff, it's okay. You can also just move that. Oh, moved to the front. Now the moment of truth. Did I actually fix the alignment here? Or maybe not yet the moment of truth, but soon. Because here we always had the problem that the belts were not properly aligned. I think now it's better. Just need a bit more belt here. I wonder why I struggled to like pull the parts, the belts through today, because usually it was never like that much of a problem. Could also do this. That would help a lot. I think we didn't quite. Here we go. There was a bit of like bit of material. Oh, you don't see anything. There was a bit of material here from the mouse ears that we didn't clean out. Let's put in the tensioning screw from the top. Oh, that's the wrong screw. And then we can pull. I think it's actually smart to just start with this side. Maybe that's why I have so much trouble today. Because I start with the rear side, I should start with the front. Okay, so these are ready. Let's go to the other side. Let's do the same here, where we unscrew the pulley of one. That this is basically, man, I'm sorry, I'm super bad with the camera right now. That basically the pulley is loose on one of the belts, that like we can tension one side without affecting, or like one belt without affecting the other belt. Okay, here we already have it in. Let me just undo the tensioning we did here. And then we can take this one. Pull that through. And slide it in. That actually works quite well. And later we can add a zip tie through here in a loop to prevent that belt from coming out. But I don't think actually like there's a high chance of that happening. That was a suggestion of Steve to add these zip ties, and I think it's a really smart solution. Okay, this is the last block. Let's actually also just flip it to the back. Or to the side we had it, right? Goes through here. And then we just pull this in. Oh, yeah, we have the same issue. There's like some leftovers from the mouse ears. There we go. This goes over the idler. Okay, I think it's easier when it stands. Oh, it's in. Ah, here we go. So all 4 belts are in, and now we just need to make sure that they're tensioned to the same tension. So I don't know. Let's just start with this one here, which is somewhat in view. So I think we're aiming like around 2, I would say. So let's just go for 2. Looks good to me. That's 2. Yeah, definitely here we could have had like one more tooth of like tension. But it's a nice thing of this tensioning mechanism. Like you can really tension like a long range. Yep, that's also true. It's a very cool tension gauge. Yeah, you can print that. Like you can get it's a kit. It doesn't want to focus. But yeah, it's a kit. Focus. Here we go. It's just a kit for all the parts, like 10 euros or $10. You print the parts, and then it comes with I have it over there. Like it comes with like piano wire, which the piano wire gives you exactly 1.9, and then you can use the piano wire to like calibrate it. And then it comes also with like recommendations for the Voron printers, basically, like what values you should have on your belts for your switch wire XY or XZ and stuff like that. Sometimes it's a bit fiddly to get it right. Like sometimes you measure like a couple times and you always get different values. But I feel like I get more experience in using it. Like what I always do is like I always twist and then I release the tension and like measure again. And then like if it goes back to the same number a couple of times, you know it's like a reliable good measurement. Okay. One remaining. Oh, would have helped to put the tensioning screw here, right? Would have been like a good first step. That's also true. Yeah, it's also like that's something I don't quite understand yet. Like you see, like this side is now like super floppy, and this side is too. So I'm not quite sure. It's maybe because it's like all the way at the end. Yeah, so like this side is a bit floppy. That's only for this one. Let's quickly recheck if the tension is still too big because I think it's not. No, 1.5. Who would have guessed? Here we go. Yeah. Now they all feel the same. Cool. Then let's not forget to retighten. Have you tried using the app? That sounds, yeah, I don't like the app. Like it's very unreliable, in my experience at least. I also heard like other people say it's like really unreliable. It really depends like how you plug it, whether you use your finger or like a screwdriver or something. Let's make sure all the pulleys are fixed. Okay, that should be the bed mount. I've never tried an app or a tool. I just use poke test. You must have really good ears then to hear the frequency. Yeah, but like I think generally it's fine. Like you shouldn't like over tension them like crazy, and they shouldn't be loose. And then everything in between, I think, is okay for the most part. I have these like glued on rubber pads as feet at the moment. I think important is just like that it's like racked. Like if you like move to the end that like both sides touch at the same time, then you already know that like the tension is the same, like for the Core XY system. So like, the tension is equal, I think is the most important part. Yeah, I can already tell you that like now the belts on the back are fixed. They're like all like, if you now look at it in the back, they're like all now in one line. Before like there was like a little bit of like a tilt basically because like the mounting points were like offset in Y. Okay, let me get that on top. Oh yeah, the other thing is like the mounting holes for, or like mounting holes, like the holes for springs were not big enough with the last version, so I just increased it a bit. And it seems to be much better now. Let me just fix these two in place quickly. Just so we don't lose them anymore. I'm very happy it fits. I think. It fits well enough, at least. Yeah, no, it looks good. Like, because now before we could basically adjust the position of the rear ones, right? But now because it's completely fixed, like these holes need to be perfectly aligned. And the last one. I still didn't print like a cover for this. It's also like excellent waiting to happen. Yeah, I mean it's not level at all, but it's in place. We can level it out. Just with Mark 1 eyeball leveling, just make sure it's like somewhat in line. Just it's like not completely out of whack. It actually makes no sense because like left right could be completely different. Okay, yeah, these are kind of like all the things you wanted to change. I'm not going to change the servo arms yet. Let's just quickly use it as is. Um, let's quickly look at our wiring mess on the back. So before we had the wires mounted to this here, and we also had these two end stop wires. Let me just like park them for now. Like the end goal would be to get rid of them, but for now, let's just kind of get them out of harm's way and then leave them here. So my idea would now be to kind of like just make, oh, this one is the servo. We need to reconnect the servo as well. For here, let's just make like a bundle. With these Velcro zip ties. And then it's just like dangling there for now. Let's actually use one of these two. Not nice, but works for now. Like in the end, like there will be like a cable channel going up here. Okay. Let's take care of this one. Just put it under here. This needs to go here to the servo. And then before we had like two zip ties holding it in place. I think I'll just add one there to prevent it from being snagged anywhere. And then this is up and running again. Okay, I would say let's boot it up. Level the bat. We have to change the end stops. Let's not forget the end stops. But let's boot it up. Let's turn off the power. Okay. I mean, there's no magic smoke because we didn't change anything electronic-wise. So that's relatively uneventful. Okay, so now basically we don't have Z end stops anymore, which yeah, prevents us from homing Z. So my idea basically was that we use sensorless homing on Z, which usually you don't do because it's not precise enough for like consistent first layer. I really have to like increase the holes here in size. Like it just works, but not ideal. Let me just show you. It saw like it looked to be very big in CAD, but it's just like barely big enough for the belt. Like we now know the belt's perfectly straight. That's good, but yeah, a bit too tight. Hi there, Ravenskeeper. I was lurking on YouTube on the phone while eating. Now it's Klicky time for this guy. Well, yeah, sensorless homing first. Otherwise, we don't get Klicky out of the dock. So yeah, like I never did sensorless on X. I think it's quite a stupid idea in general. But so my idea is basically that we have sensorless homing on Z, which gives us like a okay-ish Z. And then we pick up the probe, and then we do a Z tilt adjust to like synchronize the two motors. And that should also give us like a more precise Z. Oh, I was like, why does this is not coming online? I think this cable is important. There was the power cable of the Pi. We kind of need that. We kind of need that. Let's give it like another 30 seconds and it should come online. Here we go. Cool. Yeah, let's just dive in. So technically all we need to do is the end stop. And we also need to set the jumpers on the board, actually, now that I think about it. But let's just copy the config first. So we can just copy it from X or Y. So technically the end stop is just this one here. So end stop pin is not GPR 12 anymore, which was like the normal end stop we had, but it's the TMC, and then Z virtual end stop. And we do the same for Z1. And stop. And this is Z1. And then we need to set the strength. Something we need to try out. Oh, it's in the auto tune. We use the auto tune TMC auto tune plugin. And then you need to set it here. So let's just start with one. Let's start with 80, which is relatively hard, and then see how that behaves. Okay, so I have restart. We just need to quickly set the jumper. Oh, it requires diag pin config. Yeah, we need to do that. Hi there, everyone. Welcome to the stream. Hope you're enjoying your day off. Diag pin. Enable. Oh, it's in the here, diag pin. So we need to set it in stepper Z and stepper Z1. And then we need to quickly check what the diag pin actually is. So here they only label driver 1 or 0 to 3. So we need to check the diag pin is 14, 15, 12. So the step pin 23. Step pin 23 has diag 12. Step pin 23 has diag 12. And the step pin 26 has diag 15. 26. Wait. Step. Where did I put the diag pin? Steppers that. Oh wait, did I put in the wrong section? TMC. Diag. No, it's in the TMC section. So it's in the TMC section. In Y, it's in TMC section. In Z, here I put it in the wrong one. This is supposed to be down here. Step deer 23. Double check. 23 has diag 12. Diag 12. Step pin 26 has diag 15. It's 15, and the other two we didn't change. Save and restart. And now we need the actual jumper on that diag pin. Let me quickly check my magic box for some jumpers. Check what type of jumper we need. So it's these jumpers here. See, like here we have the jumper set, and for the other two, which are the Z, we don't have them set. Let's see, three more jumpers. Ooh, even have spares. Okay, this should be safe to put on while it's powered on, but generally like best to not do stuff like this while powered on. Don't do that at home. Okay, now we have all four jumpers set. They're not like in a very even like pattern. That's why I was like a bit confused right now, but technically it should be all we need for homing Z. Let's do the following. Let's actually set it to maximum sense, or like not maximum, but like a high sensitivity that like that's not strong. That like it stops really early. So here we have 80 right now. Let's just do 180. And then we can home. So it homes X and Y first for some reason. We need to check that. Oh. I pressed the settings button instead of emergency stop. Like it doesn't stop. Which is not the worst. Like nothing happens, but why does it not stop? Now it doesn't want to restart. I love Clipper sometimes. Here we go. Okay, not quite sure why it didn't stop. So let's just... Oops, goes the wrong direction. Let's just move this up a bit. Yeah, you definitely feel like the teeth rubbing a little bit there. So it's something we need to fix. It's not super bad on that, but no deal. Okay, let's quickly check why it does not stop. So we have Z on Z. Z1 with the diag pin should also be correct. Let's quickly double check the diag pin. So on the step pin 23, we have diag pin 12. 12, that's correct. And on step pin 26, we have diag pin 15. 15, yeah. So the diag pins are correct. We also set the jumpers. Maybe we need like, let's just set it to 255, which is like the maximum sensitivity. And try again. And this time I press emergency stop and I don't press settings. That would that would be quite good. Sometimes I would like to have like, you know, like big red button, emergency stop. That would be like better than like clicking in some web interface. I mean, we could do that. We could build that. For some reason, that Clipper takes forever to restart. Huh. We had it before, like a couple streams ago. Let's just quickly do like a full reboot. And while it's rebooting, let me quickly grab something to drink. I'm back in like 30 seconds. Okay, here we are. Let's see, fully rebooted. Fully rebooted. So now we have the highest sensitivity for the sensorless homing. So let's give this another shot with homing. Where am I here? And I will immediately hit emergency stop. Because it should not move at all. My printer project got delayed because I was scammed for around $100 by electronics comp. Oh, how did that happen? That sounds horrible. High realistic tech. Okay, let's quickly check the config again. Like, what do I miss here? Let me just double check also the docs. I think 255 was the highest sensitivity. Microcontroller pin attached to the direct line of the TMC29 chip. The pin is normally pre-phased with, yeah. Saying this creates the virtual answer, virtual pin, which we use. Yeah, but where's this? Ah, they can't be the only two. Yeah, 255 is the most sensitive, so I would have expected it to immediately stop. Let's try again, and I just like try to block it with my hand. Yeah, but it's like, it doesn't stop. It doesn't stop. Well-known website that's so various parts. I purchased from them before, but starting in June, they began scamming people by not shipping orders or refunding money. Oh, that sounds horrible. That sounds horrible. No, this looks fine. We have the jumper set. What do I miss here? It should just be sensorless homing. Um, yeah, we changed the end stop pin to the virtual end stop, which we have. We set the diag pin, and we set this to 255 initially. Then we do it for X and Y. We now do it for Z. Mm, let's quickly double check. So for Z, we have the end stop pin set to the virtual end stop. I wonder whether this is like doing weird stuff because we have the auto tune here. Maybe let's comment out the auto tune for now. And manually set that. Maybe the auto tune says like you don't need that because it's not really like common situation to have like Z on sensorless homing. So we now set this here. Yeah. Complaints to the consumer form. Yeah, if you use PayPal or something like to pay, you can also try to get your money back from there. You will not have that in your stepper config of the add-on. What do you mean by stepper config in the add-on? Let's try again to home. Oh, I lost one of the... They really stick horribly by now. I need to replace them. Okay. Let's home again. Yeah, now it did it. Now it did it. So the problem is the TMC auto tune. Potentially, all we need to do is just set this manually. I assume the TMC auto tune just doesn't support this value here for Z because like no person would use that for Z. So let's just, I mean, we saw it worked. So let's just set this to like 160, which is a more realistic value. And just try again. Yeah, but now it's already too strong. Like if I hold up the printer on it, like, let's see. So 160 is no good. Let's do 200. I feel like because we have such a like big gearing ratio in the back, maybe it's needs quite sensitive values because steppers have a lot of strength. That's actually two. Yeah, let's do 200 for now. And let's also move the bed up a bit again. Now I have a bit more like leverage room. Oh. Wait, could it be because now we commented it back in? Wait, where's that? Could it be because now I added the auto tune again that maybe now it's just not working again? So let's just leave the commented out for now. Maybe that's the issue. That like as soon as you put the auto tune in, like it doesn't work anymore. So let's home. Yeah, now it's doing this again. So now it's like too sensitive, of course. Well, actually, like it worked, like it homed. Um, so let's just try 140. Because now it was like too sensitive. So basically, like the first run was 255. It was so sensitive that it even like when it retracted, so it was triggered. Now it was like it moved slightly down and then got triggered. So hopefully now it should be. Yeah, yeah. Now I. That's the problem with two motors. But here, Steve, that's what I mentioned. Like it can still be a little bit like on the axis. It has enough flex, which not sure if that's a good thing, but ends up still triggered after retract. Well, let's move this a little bit up. Why does it say end stop Z still triggered after retract? Maybe the value is too sensitive. So let's do 100. Oh, that was the wrong one. 100 here. And 100 here. Let's try again, step by step, to get it to move 5 up after. Can I set that? Retract. Oops, that's the wrong. Homing retract dist. And that goes in the stepper section. Let's just do that. So we just say homing retract is 10. There's, yeah, we already have it. Homing retract is 3. Let's just set 10. Should have it on X and Y. Yeah, we also had it on Z. But like if you have two Z motors, you can the Z motor basically has way more settings than the Z1 because they need to have the same for most. Let's see. Oops. But basically just like went over the teeth. So maybe 100 was a bit too much. Let's go back to 160. Is it safe to buy from BQ? Yeah, BQ is Big Tree Tech. That's I would say like a very, very reputable seller. If you buy directly from them, might be a bit cheaper than if you buy from AliExpress from them. Yeah, like I ordered tons from BQ, but via AliExpress, but from the official store. Okay, let's try it again. Oh, it worked. No, it didn't. End stop still triggered after retract. I see this might not work. I think it really comes down to having the right value. I have a backup plan. I have a backup plan. I had the same issue like that and it would not let me do this retract after homing till I made the homing macro. What do you mean by made the homing macro? Do you have like a homing routine, a custom one? It doesn't do it. Ends up that's still triggered after retract. Let me just play around with the value a bit more. That. So we now had one, but 120 we already had issues that it didn't stop. AliExpress is banned in India. Oh, that sucks. Yeah, you can also buy from the webpage. I think that's pretty much the same. Let's home again. Yeah, it's the same now. So basically with 120, it doesn't detect the end. Did we ever tighten the screws on this side? It's kind of unrelated, but no, we didn't. That's good. It's here to really stand out. These are kind of pointers anyways. Did you use cable sleeving or drag chains for your ender wire? I used, in the beginning I had the drag chains, right? But then I switched to a canvas tool head. And since I have the canvas tool head, I have like umbilical cable. And there I have the cable. I mean, for me, it's only one cable because it's the canvas. But basically, I have the cable, and then I have like, I'll say, okay. Then I have like solid core wire wrapped around it to make it a bit more stiff, and then I have a sleeve around it. That's kind of the setup I have at the moment. Okay, I think this is kind of like a non-starter, which is sad. I hope this would just work. That's weird. Like, I don't see what the problem there is. It lowers the current for all homing sequences T. That was X and Y though, and not for Z. Yeah, I think, I mean, we can try it, right? Like we can just lower the currents for now and see if that like helps at all. Although the current isn't super high. So we can set a run current to 0.2. Let's just set it really low. Z and Y. Well, Y does not have. Oh, for Y I have a drag chain. The same, still the same setup as I had in the beginning. And Z I actually also have a drag chain, but the only thing in the Z drag chain is the camera cable. So basically, like the tool head's directly connected with the umbilical, and the umbilical goes to the top bar basically. We worked on the ender wire 2 weeks ago, so you can also check the stream from then. There you see the current setup. There's also like a good one, T. Maybe the retract after home should just be 0 because we don't have a retract here, right? Homing retract this is 0 here. Let's quickly try it before changing the current. Because I never had the retract dist on, now that I think about it. sensorless homing. I never had rejectors. Let's try this. Hi, Design Sniper. Welcome back. The reject is what triggers the end stop warning. Yeah, I think that might just be the problem. Wait, let me quickly move it up a bit again. Here we go. Yeah, that was it. There shouldn't be a retract test. Okay, here we go. Now it's homed. It's homed very badly, most likely. But then basically my plan now is to have a homing macro that now deploys the probe and then does the Z tilt adjust. Send macro on Discord. We'll have to add that. Macro on Discord. Oh yeah, so you reduce the run current in the macro. And then you wait for Stargard to clear. Yeah, that's good to see. So this seems to work. I think also like the value seems to be quite okay. And then let's just update the homing macro. So let me think. Let's quickly check that the bed doesn't collide with the nozzle. That would be like step one. But then the height of the dock here shouldn't have changed at all, right? Because we changed the bed, of course, but this should, I mean, it might have changed. Let's double check all the Zs. Because I think now we are like homing on the bottom, like a bit deep, like a bit lower, because before we had the switch poking out like 2 millimeters or something. So I assume the dock is now a tiny bit too low. So let's do the following. Let's just go to Z10. I should have not gone to 10 right away, but it worked. Maybe 50 would have been a good step. Let's go to 5, seems safe. And then let's just go down in 1 steps. So now we're supposed to be at 0, but we still have like quite a bit of room. So let me just, yeah, like I put the bed quite a bit down. So let's just do the bed level now as a first step. Yeah, and again, like the Z answer position is off now. I think that's the root cause here. Looking at this, we can adjust the Z answer position maybe a bit. So at the moment, we have a Z offset. Position ends up is 181. So I think we can just increase it to 183. Let's do 184. And then like the stuff we change here doesn't need to be that big. Current speed, sensitivity, and all that. Yeah. And the spring leveling is also changed, Steve. Yeah, 100%. It's like, but I think the main issue we have at the moment is that the old parts. If you look here, the end stop was lower, right? So basically, it triggered basically when the button was pressed, right? But now it triggers when the plastic parts connect. So it's just like, I would even say 6-7 millimeters different than before. And then the bed, of course, right? Like that's still like a thing. Let's quickly home. Might be a bit too hard, actually. Like maybe we can make it a bit more sensitive. But yeah, homing macro incoming. Let's just go to 20. And let's just go to 10. 6, 5, 4, 3, 2, 1. That was actually quite well estimated. Like we now have like 2-ish millimeters, maybe a bit more. So let's just do. I never remember that command. Level adjust. Ah. Clipper bed screw adjust. Bed screw adjust. Okay. Paper. Yeah, kind of fun. You should use Y to home before X as well, so the toolhead doesn't crash into the corner. Oh, you mean here in front? Yeah, that's a bug in the parts. Like these should be lower. That's yeah, but actually like reversing the order for homing would also help there. Okay. Let's do one more round of that. Okay, that's good enough. We do have a Klicky probe after all, right? So, let's just abort that. Cool. How was it? If we do G, let's just do SS deploy. So that servo works. That's good. SS retract. SS take probe. No, that does not work. It now has it like in a really odd way. So maybe we should have tested the position before. So if we say SS deploy, we now have it up. And just looking from it, like it needs to be quite a bit higher now. So I'm just trying to like inch it forward. I'll just see if I can give you like a better angle of that. So, oh, it makes sense to move forward, right? Yeah, it still bends up a bit, so let's just go down. Oh, that's the wrong direction. So I'm just looking that this is like, has no tension on it. Yeah, now it's in, and then we can leave it. So the Z height is 8.1. We need to change this in our config. Still have to clean this up. It's like super messy at the moment. Yeah, so it changed by like 1.5 millimeter. Oh, no, I touched my glasses. Okay, let's just do a full homing. Oh, I almost picked up the probe. And then like what we need to do is clipper Z tilt adjust. Z tilt. So we need to check this. This is something we need to configure now. So basically use the probe to like level out the motors. But before we do that, let's try to take the probe. That was a bit too fast for my liking. And I had very bad reaction time, but it works. By the way, one problem, now that you see it just now here, you see this one, it like leans outward. That's something we have to fix at some point. Like there's something wrong with this part. Let's just home this. But it stopped, so we can do it again. It works. Now we have the probe picked up. The only thing is like we added this like drop off the bed that the switch here doesn't collide with the bed, and that's not high enough now. But I also printed the longer arms, which yeah, let's not install it now. Let's just change the macro quickly. The take probe, and then Z instead of 5, we just do 10. Let's save that. Let's first store the probe. And then we can restart the firmware. And then, wait, did it not restart? I didn't see it. Oh, it did it. I didn't see the restart. Let's do home and then just make a mesh. Yeah, now you saw like the bed dropped more, and now like the switch here is above the bed. Okay, let's just do like a quick mesh. One thing that I noticed now already, last time we had massive issues with the inconsistencies. So it tried like up to 10 times on one spot and then said like, oh yeah, I cannot do it. There was like not a single time the case now. So I think the fix we had with the belts in the back, with the belts being out of line, that definitely helped. I mean, this looks weird still because like it's at 2.5. I'm not quite sure why this looks this weird, to be honest. Most likely has something to do with Z0. Could also be that the probe Z offset is just incorrect. What do we have as probe Z offset? Because I copied those values, but it might not be correct. Probe Z offset is 10, according to this config. 10 millimeters. Shall we just give that a check? Just like a quick reality check to see if this is like realistic or not. Could have put it down all the way, but. So looking at this, I guarantee you it's more than 10. And this is most likely where it breaks. So this is more like 15. From the nozzle, it's 15. Oh, no, it's not 15. Oh, who would have guessed? It's pretty much exactly 2.5. So I think that the probe offset is just incorrect. So let's just set the probe offset from 10 to 12.5 and do another mesh. Okay, so let's just manually store the probe. And then if it at some point Clipper gets a hang of itself. Yeah, like sometimes it just doesn't come back online. It's super weird. It's not a waste of time, let's just reboot the whole thing. Yeah, this looks pretty cool. Now the mesh should be around 0, I guess. So then everything should be in line. So then basically next step would be to do the homing macro and to set up this Z tilt adjust. Where do we have it? This one here. So we set points. And then the interesting part is like, does it pick up the probe automatically? I think before we run Z tilt adjust, we need to pick up the probe. So we need to override that macro most likely. Okay, so okay. Let's quickly try if I say calibrate here. Exactly, it doesn't pick up the probe. We also need to check the macros there. So let's say SS take probe. Yeah, now I did it again multiple times. Yeah, now we are a bit too low, but like the range is more reasonable. Like now we are 0.5 too low. So maybe the probe of that is more like 12 exactly. Let's try one more time and then we can call it a day. Find a minor glitch in Octo app. Just send me a bug report from the app, please. Main menu, settings, FAQ and help, report a bug. So yeah, just main menu, settings, and then FAQ and help. Just make sure to recreate the issue and then send the report right away. Okay, that's home. Yeah, like it uses bad mesh calibrate here. So I wonder whether we should just override bad mesh calibrate to take the probe. Let's just quickly do that actually. Because then we can do the same for... Technically, it should be the same as here. G29. I just wonder, like, I don't think I use bad mesh. I like G29, so let's just change this to bad mesh calibrate. Oh yeah, here. And then there's a thing. Oh no, because bad mesh calibrate gets parameters, and you want to pass on the parameters when you override. And I fixed that for Nomi, and they did not merge it, of course, but fix it up to bad mesh. I had the exact same issue with Nomi because also Nomi overrides the thing. Yeah, and then rename existing, and then it's the raw params here. So if you do this, basically whatever the overwritten macro gets as parameters, it just passes on. This one, it's the BTT, yeah. Yeah, so this way, basically, there's we just override the existing macro. While we are messing with the config, let's also just quickly throw in the Z tilt. Just to keep some form of order here, let's put that, yeah, maybe here with the bad screws. Z positions. How does it work? A list of XY coordinates, one per line, subsequent lines indented, describing the location of each bed pivot point. The pivot point is the point where the bed attaches to the given Z stepper. Well, that would be like just like the center, left, and right for us, right? So we need this. So this would be, I mean, the X doesn't really matter for us, right? So let's just say 90 because it's half, and Y, like, let's just say 10 and 170. Oh, 165, I think is what we have. And then we have wait, 1090. Yeah, we have here also 165, 90. So it's like in the center. Then the points to be probed. Let's also just probe the same 2 points. Speed, let's just leave default. Horizontal move that, let's just put this to 10 just to have bit room. Retries, let's do 5. Let's just remove these. Okay. Save and restart. Anyone here played around with one of the many Clipper config auto backup scripts and macros? No, I did not, but I wish I had, because I had some accidents. But yeah, like what Steve already said, like technically you can just set up like an rsync job. So if I now set, oh cool, there's a new button, Z tilt. So let's do the following. If we now calibrate, it should pick up the probe. It does pick up the probe now. Okay, cool. So this override is successful. Here we have a mesh, and it looks like a mesh. And it puts away the probe, which is also nice. Cool. Let's try this Z tilt adjust. Can't be less than probe Z offset. That's smart. So our config is incorrect. Horizontal move Z. So let's just do 15 then. Let's do 20. You need to pick up the probe before Z tilt. Yeah, that's also true. We didn't override that thing, right? Let's just do quickly. I really wonder whether we need the Z tilt adjust at all, to be honest. Because we do the sensorless homing to the bottom, right? It should be straight. And then whatever is not straight, it just can do with the bed mesh. But let's try it out. So where is it? Where did I have to? I have so many stuff open. Z tilt adjust. Mm, so we can just one-to-one do the same. Your question about the magnet, I did. Is the front magnet on your Klicky probe wrong? It always looks like there's a gap between the magnets. There's just the screw head stands out like a tiny bit, but it's kind of on purpose. Like that's what you see, I guess. I found it nice if there's like a little bit of like a distance or like a gap between the magnet and screw. So what do you mean here? Here it's nice. Let me see if I can. Does it focus there? I mean, this looks fine to me. Like there's no gap. Like it's a little bit more to the front. No, it looks fine. Could be the shadow, yeah. That's always a bit with the lighting. Let's see what this has for MCU issue. Can you do the sensor Z homing and then manually run Z tilt and see how ideal the result of sensor is? It's actually a very good idea, ballistic tech. Let's, as soon as my clipper remembers how to clipper again, we can do that. Let's just reboot the whole thing again. Like something is wrong with the restart, but I have the same on the Enderwire sometimes. That like you do a firmware restart and it just doesn't come online again. It's just gone. I have no clue what happens there. And yeah, the quick is always just a reboot. It's interesting, like the bells just like in these like holes here, like they it doesn't rub. Like I don't hear clicking. Like in the beginning I heard it, but now it's gone. But yeah, this should be like a bit bigger. Okay, so we do we just home. No, but there's no vibration or like sound when it like moves out. Yeah, now you also saw like this one like this side home first, and then this one was like doing this basically. Let's do Z tilt. Oh, ooh, ooh. Always be ready to emergency stop. That would not have been good. Just like prop next to the bed. Okay, let's just move that like 10 over. So let's just actually do 0 and 170 here, because I think the actual tilt point would be more accurate here. And let's do 155. Put the probe back. And let's home. As a Raspberry Pi for be 4 GB enough to run Clipper? Yeah, 4 GB you don't even need. Like I would say 2 GB if you get a lot cheaper is sufficient. 1 I wouldn't do. 4 is more than enough. Well, I did it. It was still like probing very close to the edge, so I think I'll just move it in like a tiny bit more. Just like for my personal comfort. Let's do 45. But does it print the results? Yeah, so here are the results, Ballistic Tech. So it's actually quite significant. It's minus 1.5. So it's like two layers, basically. 2 layers of like shift left to right. But again, like I feel like the bad mesh should like take care of it quite well. Should be more than enough. A 0W can run Clipper. This one is a 0W too. Pay attention, there's this W, like the 0, like the original 0 and the 02. The original 0 I wouldn't do. Like that is quite a horrible experience, but the 02W, perfect. Like more than enough. I hate that tilt. When I redo my printer, I'm making it fixed. Yeah. I mean, for me, because I have 2 motors, like I kind of need it because you kind of have to synchronize them somehow. But yeah, I think that seems to work. So we have the bad mesh working. It's all kind of fine. Do I have a homing override here? Doesn't seem like it. G28. No, I don't have a homing macro here yet. So let's not start that. I would say, was there something to enable for adaptive bed meshing? I think it was just in the start Printy code. Hmm. Yeah, I think it should just be my Orca config, to be honest. It's a 10 little difference, so I'm going with 4 GB. Then thanks for confirming it's enough. Yeah, like it's plenty. I wait for 20 though, so that's a long process sometimes. Yeah, okay. The bigger the worse, I guess. Oh. I did not set it up. Orca. It's just a new project with that's so annoying. Like I cannot rename that in Orca. I have to set up a new profile. It's super annoying. Or a deep dive into the config. Let's just do the same Voron cube I showed before. So we modified with top shell 0, infill 0. So it's just a hollow model. Experts in 3D printing say you also need filament, which I don't have. So let me grab that. Right back. Magically filament appeared. Let's also quickly check the start G code. Oh wait, I have a separate macros file. Hey. So the start print, but I copied it so it has the adaptive math mesh setup. Here, I commented out. Bad mesh calibrate profile adaptive one. So this is now possible. We can do that. And besides that, we wanted to invert the order of homing, right? Print end, center, front, back, homing override. I guess we can do it like this. Let's quickly check if that homes. Yeah, now it's Y, X, Z. It's a very bad homing override, by the way, because it doesn't like the buttons, all three buttons do the same thing. So cool. Yeah, let's start the print, right? So this should take 18 minutes. Oh no, I had that before. I had to. Sometimes Orca is a bit stupid. Let's start a new project. Transfer. Handy model, Voron cube, slice, print. Okay, Orca is like. I am on the beta. I am on the beta. I did not update. So I don't want to blame Orca too much. So right now we're heating up the tool head to 150 and the bed to 60. I am hot on the emergency stop button. Oh, we wanted to add the Z tilt to the homing. I totally forgot. But yeah, it's already homed and Z tilted, so for now it's fine. Can be long process. I try to leave the machine so I don't have to do it each time. Well, yeah. My mini SPs are able to grab the filament pretty well without opening the tension arm thing. Yeah, like I also noticed that like you can basically just push it in and it will just like grab it down. I actually do that when I do like filament changes during print. I set up the distance in a way that like it basically shoots it out completely. And then I just press it in when it like loads new filament, then you have the correct distance because otherwise you always end up with a massive blob on the bed and like everything just a disaster. Common, you have named the printer? Yeah, like it's in Orca it has like the weirdest name ever because like that's what we chose. It's myself model 1 0.4 nozzle and I cannot change it. Oh, it didn't grab the probe. Well, I did not grab the probe. Did I? I think I accidentally changed something in a probe. I think what I wanted to do. No. 168. Because like it's definitely not far enough over here. Okay, let's do the following. Let's do first the homing overrides. I'm not quite sure what I'm doing here, to be honest. Was it bad tilt adjust now? Hey, let me start closing like some of the things I don't need anymore. Z tilt adjust. Save and restart. So now it should do the Z tilt adjust when we home. For the homing override, should you move the bed down some before doing X, Y, just in case? The bed is on the bottom. It's all the way on the bottom after homing because we home to the bottom. Do Control Z and see what change. I don't think that works like that. Like after you like restart and stuff, like it's all gone. Change the G1 part to do first, then do the X on homing. Now restart. I hate this. This is so annoying. Wait, let me check. I always have my bed move before X and Y. I mean, technically there should be like a lot of ifs. There should be like if you want to home X, Y, Z. Like I have a way better macro for the switch wire. Actually, I'm really not sure what this is supposed to do. It just moves somewhere. Okay, let me restart this thing again. And move your G28, 28X and G28Y. But Steve, like I'm like this G1 stuff only moves it away. Like it's basically like a homing retract. Right? Like I need to home first so I can do that, I think. Here we go. Okay, let's quickly check the pickup position because it bothers me a bit. 168. Yeah, let's just home. And that should do the Z tilt as well, which might be a problem. Yeah, it's definitely not where it's supposed to be. What's the problem here? Do you mean this, Steve? But yeah, it would be better to home the Z first, actually. You're totally right, T. Yeah, it's still not correct. But I think it has something to do that it's like during homing. Because like also the position is incorrect. Like the position it shows in Clipper is incorrect. Okay, let's quickly change the order here. Let's just do it like this. Let's remove this. I want to print. I don't want to figure out the stupid macro. Now it does that first. Now the question is, because I have G28YX, will it home Y first? No, it won't. So I think the order of the parameters for G28 doesn't matter. Okay. And if I now do Z tilt adjust, no, it's wrong. No, it's right. Now it works. Okay. So it has something to do with that the Z tilt is done during the homing. It's when we coming here with the macro, yeah. On my endo wire, it took me forever to like get something working. Okay, so now it's fine. Let's just print. And then, yeah, it's like 10 millimeters off. Like when it tries to pick up the probe during the homing, like it's just 10 millimeters off. I don't know why. It's really weird. Yeah, and this here is bit crooked. But yeah, it seems like that the bed mount in general works now really well. I think that's something like we can work with this one now. I don't think like we have any emergency changes. Like the suggestions from T and Steve are great that we get, like make this more modular. But I think technically this works. Like this is like a working solution now. And this is now also like really like stringent. And by the way, we didn't adjust the rods or anything. So I think they were either already okay, or this like somewhat flexible mounting system we had before for the bushings. It's flexible enough that we can adjust a bit. So let's see. But I think the next issue we need to figure out is like there's like still like quite a bit of like, you can see it, right? So something is wrong with the bearings here. It's either the bearing has too much play on the rod, or the bearing has too much play in the housing here, like in the housing. So that's something we need to figure out. Definitely not adaptive. Uh-oh. I tried quite a lot there now. Yeah, but this works really well now with the stone. Like it barely takes any time. That's pretty good. I like that. Next time we work on this machine, we add the tool head LEDs. This bothers me every time. Like there's like, it's so dark here. Like you can barely see anything. So this like next time, I still have two, because like they come in 4 packs and we add two to the V0. Like this is the next thing we add. It's like top one priority for me. We made a lot of progress this time. I think last time we made more progress, right? Because like we didn't really like change anything this time. It's just like we redid the bed in a certain sense. Last time we redid the bed, added the probe, like redid the bed in a way more dramatic sense. Let's put it like this. Thank you, Eric. Great progress. Yeah. I mean, if I imagine like a couple of weeks ago how this machine looked and like it barely moved, or when we only had the top part, right? Like it was just the top part on the table and we didn't have any Z. It's also like not too long ago. Like I didn't work on the machine for some time. But yeah, like it's a functional printer by now. Like it might not print like the prettiest, but it's functional. Oh, sorry. I was centering it on the screen here, but didn't notice that like there's some chat stuff here. Actually, Z offset is somewhat okay. It can be tuned, but it's actually quite a speedy machine. Like we still have to figure out that why, which for sure is part of the cause of the bad surface quality, but it has no problem moving fast. I actually also swapped the nozzle. In the beginning, we used this fake CHT nozzle, and now I just swapped out to the normal V6 nozzle that came with the, was it mellow? Whatever, price act? Mellow? I think it was a mellow V6 hot end. But yeah, I just swapped in this one because I figured maybe the surface tension or like the surface quality had something to do with the nozzle. But yeah, no change there. I want to see the input shaper graphs on this printer. I haven't seen anyone do them on a full linear rod printer. The X one looks quite okay. Y is horrific. And horrific beyond horrific. But I think it really has to do with like the XY joint not being stable. So that's something we need to figure out. But input shaping makes no sense as long as like there's like that much like wiggle on Y. We can do an input shaper run after the print. Like we have a canvas tool board by now. It's kind of like a premium machine. So we can just run the input shaper without any issues. I had so many issues with TMC 2209, so I switched to TMC 5160s, and it's been amazing since I made the change. I have actually 5160s inbound next week, and they will go to the EndoWire because the EndoWire will make a big transition. The EndoWire is kind of like an endless project. It's never done. Yeah, but we still have the same bad quality on the surface, especially on Y. Sure, can we see it? Like it's a bit really difficult to see on camera. Trying to. Yeah, but here you can see it now, right? Like on the side, you see like this like it's not even like a orange peel surface. Like it's just like a really weird surface. And like I'm not figuring out where it comes from. It's more on Y than on X, but also on X a bit. So it's just a bit weird. Increase the temp. Temp is already 225 for PLA. Oh, we can increase it. Let's just do 240, which is like, let's maybe do like 235. Just see what happens. Yeah, let's also make a small dot where we change temperature. And I didn't play around with temperature so far because the material I also use like on other printers. And 225 is what I printed at. Like that works well on all the other machines. Same for like all like extrusion factor and stuff like that. It's just the material I use since like 2 years. So I was well tuned in. Again, it's of course always a bit different between the machines, but in general, it shouldn't be like this dramatic. We start getting a bit of stringing now. I think you can actually see like a small difference, like here where we started. Like the surface definitely changed. Like when it's in the line, you can see there's like a small line. I think around 230 on mine, but I'm at work, so can't remember. Well, I think for PLA, like 230 is already pretty damn hot. I mean, like now with all the high speed stuff, like you print PLA a bit hotter than you used to, I think. But I think in general, like 225 is already quite on the high side. Maybe we can try lowering it actually. That would be like another. And I also like never printed any other material than exactly this PLA on this machine, so would also be just worth trying something else. Yeah, but to me it looks more like a mechanical issue. Like it could be with the extruder, but it could also be just with the motion system. And at the moment, my guess is just like that it's something to do with the y-axis being quite sloppy. So it was still be like my number one culprit. And I think as long as like we didn't fix this, I'm not going to search for something else. Like this is like a known problem. So my next goal is to fix the known problem. Actually, like I think what is part of the problem for the y-axis is that I had a piece of paper right here. So how I modeled it in Fusion is let me just quickly. So in Fusion, I modeled it like this. So the bearing is in the middle. But then basically my idea or my thinking was that like if I have a circle on the outside for the clamp, because like the printer never does a perfect circle, it's like too tight. So my idea was like to just contact it on basically these four sides here. But I think that just causes it to wiggle. So for what I did for the back side here, for that for a new one, I just made a perfect circle, just like a normal circle on the outside for a clamp, and it worked really well. I also saw that the Rook also uses the same linear bearings for at least that, I think also for Y, like the original Rook. And that's also just like this. So I think I will just rework the parts to be like this, like here, and just reprint them and see what happens. Can you test how much the tool rotates? That might be another issue you can fix when you're redesigning the XY joints. I'm not gonna redesign the XY joints. I will just change the shape. That would be like my first attempt. Like I'm not gonna. I kind of fucked up there a bit. So basically, the XY joint is the most central part in the entire machine. Like, it's the first thing I designed, and everything in the machine kind of references off the XY joint directly or indirectly. If I change the XY joint, it's always a massive pain. So even small changes in the XY joint are really like painful. So hopefully I don't have to redesign them. Using a clamp, I think circle is good, but if it's a press fit, hexagon octagon would be better. Yeah, I think it's like for the, because I really do use a clamp, right? And I think that's just like not a good setup. So my current theory is just that the bearing is like wiggling inside the XY joint. But I fear that also the linear bearings I have at the moment are not super tight on the rod. So maybe it's a combination of the two problems. Hmm. Yeah, let's see. Because I remember with Monik we had like a discussion all in the beginning of this machine between linear bearings and bushings. And I had bushings on the rods for quite some time. And then I did the input shaper tuning, and the graphs were horrific. And I figured that there's too much like friction basically between the bushings and the rods. So I switched them back in the super cheap AliExpress linear bearings I had from all at the beginning, and they gave way better input shaper results. Like it was really like it was a peak, and with the bushings it was just like mush. So that's why I have now the normal linear bearings again on X and Y. On Z, I still have the bushings. But in basically linear bearings, they have a little bit more play around the axis. So yeah. Did you run the calibration on the table or on a solid surface? Solid surface. Lessons have been learned before. I was chasing like weirdest behavior on my ender wire for like the longest time until like I realized it's this stupid table. And this table is really, I hate it. This table is horrible. Um yeah, but it's the only table I have. But yeah, it's really like you see like when you see here like this is just like me like moving the table with my hand a bit. Um I'm moving to a new place in optimistic 4 weeks, more like 5 or 6. But in the new place, I have a new table, and that table is mounted to the wall. So that should solve this issue for good. My lens was not going to be happy with me. I bolted the printer table to the wall. Yeah, that's exactly my current situation as well. And also this table here technically not technically belongs to my landlord. So it's the same surface as the kitchen counter. So I didn't want to like modify the table. But yeah, like I feel like if you want to do like any serious work on a table, it needs to be bolted to the wall. Otherwise it's like pointless. It's really annoying. Like also here my camera arm is like not the most sturdy. So like whenever I work, and I'm really sorry for that, but like if I do something on the table, like the camera starts bouncing around. So yeah. Let's actually print now with 215. See what that does. I don't think there's any difference, but Klicky mounted. And had to do some config magic. Well, always be ready for two versions to stop. Another thing when changing linear bearing area, make sure you account for the overhang issue. Like do a teardrop shape or 45. Yeah. At the moment, I print them laying down. So I basically print them in this orientation with like the print bed being here and then printing the arc like this. So I don't think this affects me at the moment. But if I do it round, I definitely do the teardrop to wherever is top, depending on the print orientation. I need to double check that. No, I think the oh yeah, actually the one part is there would be needed. But yeah, I'll make sure I consider that. Put your hands on the motor. Not significantly more. I mean, also like at the moment there's like the notch on Y, so it's not the same movement. Let's wait until the overhangs here are done. It's like a perfect square. Then I think it's a better comparison. And you also see like here now in X, it's like also like not a good surface. I mean, it could still be like the XY joint because obviously if that wiggles around, like it also will affect the X. Okay, let's see. Feels the same. There's no difference between X and Y movement. It's a good idea, but I don't think that's the reason. Adjust the resonance issues with TMC 29s with the Y movements. Finally had enough and moved to the TMC 5160s. Not sure what it was. Yeah, maybe it was just like something with the driver. I mean, they are quite different from the 5160, so potentially just some weirdness. But also like for me, what like is like absolute game changer is the TMC Auto Tune plugin. TMC Auto Tune is like amazing. Like it basically has this like internal database with all the steppers, and some like characteristics they have, and then it like sets all the TMC values automatically, and it's amazing. Like they're like more silent and stronger. It's like really magic. Here we are. This is our semi-ugly cube. So I'm sure I can show you, but you see, like, especially here around the top, and this is reproducible. Like, there's these Z issues. This is super reproducible between those test cubes. It's always like in this area, it becomes worse than on the bottom. And on the bottom, you have this like orange peel look. Like, it's just not smooth. It's just not smooth. The X side is always better than Y, but also here you see like on the bottom, like there's this like texture. So I'm not sure. Like you have the inconsistent layers on top, and then like these like weird textures here. I haven't used TNC Optune yet. 100% give it a go. 100%. It's really good. Just Google TNC Autotune GitHub. You'll find it. I tried TNC Autotune as well, but did not have much results. Oh, that's bad. Okay, well, worth a try. But yeah, just like to show that wiggle issue again that I mentioned. So this is quite significant. Like this is really like not good. And it's not even that like there's like leverage or something. It's just like if you do it in the beginning, like directly up around the bearing, it just like wiggles like crazy. Like this is not good. And I think this just caused like a lot of the problems we are seeing. At least that's my theory. Because like on X, it also wiggles a bit around X, where we have the same mounting, by the way, but it's by far not as bad. Like the subjectively, if I wiggle the tool head on the V0, like it wiggles around the same than on this machine. So I don't think that's per se a problem, like at least like in this direction. But yeah, this is like, it's just not good. So that's something we need to definitely fix. You should do some print and chill streams or further mods. Yeah, further mods is always good. Long bearings might be better. The Warren Legacy used those. Yeah, that's also something I considered. We're getting a bit into like clearance issues here because I mean, how much? So we have around 56. I think a single one is 25. So technically we would have enough space to put two, basically. That might significantly improve it. But I first want to make sure that's not the mounting point of the bearing. But yeah, like we can definitely try to put two bearings here basically inside instead of one. I have like one flying around. Oh yeah. Like we can basically just put two and it should fit. Should. Maybe we have to prolong it a tiny bit, but no, it should fit. So technically we can have two, and this definitely will help, right? Because then instead of like wiggling around this, it wiggles around this. Might also be like interesting to combine a bearing and a bushing. Not sure if that makes any sense, but the long ones are 45. Yeah, I mean, that's also like option. These should be 50 now, right? That's 48. That might be better. That might be better. I think that's a big part of the problem is just the bearing mount might not be good. But then also like two. What I also saw that I have like an older variation of the Rook as files, and the Rook uses two on X. Like so it has two beams or like two rods, the same as I have, but it has two on the front and one on the back. But also here, I mean, here it doesn't fit. So here we would definitely lose space. So that's something to consider, but might be an option as well. But I feel like this is I mean, it's also wiggles, so it might still be a problem, but need to see. That's something we can optimize. I mean, potentially, the problem is just at the moment, if I quickly turn this off. At the moment, we already are not able to have the full build area. And I kind of wanted to have the rods in like 5 centimeter increments. So if we now say we need more space here, the entire printer will like grow 5 centimeters basically. But yeah, here we are completely docked on the side. So if we would say we want to have 2 bearings there, then we would definitely lose some space. So you say the long ones are 45. Yeah, so we have 43.75. So yeah, we lose a millimeter. That would be tolerable, I guess. There's also, I think, in yeah, like we already are losing some areas. So this is like the outmost position nozzle can reach. So you see, like we're losing like 5 millimeter each side already. If this wants to focus, so this is like already like the max. In Z it's actually a bit worse. So this is the hindmost one we can get. And then front, I mean, front is there's still the issue with the bearings, but also here, like we are kind of like, okay, just trust me. There's like also like 6 millimeters from the front. So we are still like we're already losing a bit of bad space, which is not good. So I mean, the nice thing is with these rods, right? You can really just say like, oh yeah, just make it 2 centimeters wider. Nothing else has to change on the machine. It's just you make the rods 2 centimeters wider. You need longer bells, but that's about it. What do you what made you do the linear rods on top like that? Why not just have 2 in front? What do you mean by 2 in front? You mean here? 2? This was just basically like initially I wanted to have nothing here. The idea was just it's a bit more accessible from the front, but this one needs to go to the top. Just like because yeah, here you see like you can really pinch your finger and that's not good. So this one needs to go to the top. And then these two, there's not a lot missing actually. Like this is like needs to just go like down 5 millimeter, and we have the space here to just move them down 5, and then you can move all the way to the front. The X rods. You gain more Y distance. No, actually, like the Y distance wouldn't make any difference. As if you can see like this, there's even space here, and I moved this one just back as far as possible to have the longest distance here, so that there's the longest like lever to stabilize the print head. I also considered stacked, to be honest, but this one seemed to be like a nice solution because then it's still like all level. And I don't think there's like a difference between stacking it and laying it down. Like you always have the same like level length basically. Like your legacy, the extra stacked on top of each other. Yeah, like also like the oh, how's it called? The Ender 3v3, I think. It also has it stacked. The Prusa Mark 3 also has it stacked. Like they all have it stacked. But I don't think like mechanically it shouldn't make a difference. Like correct me if I'm wrong, but like I don't see how this would make a difference. Like what's important is the distance between the rods. If it's like this or like this, like it shouldn't really matter. He's losing lots of Y space because X rods are on the top. I don't see how this is losing me Y space, to be honest, because like what's blocking me at the moment is like this here, right? Like this connects both front and back. So this is the limiting length. this here, like this, like there's gap. Like this could move further back. This is what limits me. Also like on the front. Like this is just making use of the space above the motors. Like here, that's just above the motors, basically, where like this like second rod is parked. I don't see how this like loses me white space per se. Your tool head is face heavy with the rods that way. You mean like the center of gravity is somewhere here? Or like more like here? But it will also be the thing if it like would be like on top of each other, right? Um, I mean, like this is always the heavy part, right? And unless you, I mean, I think you also suggested in the last stream, right, to have like the rods around the tool head, which I think is a really cool idea. But then we definitely lose white space because then this doesn't work here in front. Like, so if you have the rods around it, I fully agree. This would be the absolutely best like way to do it. Then you also would have like the option to have two small bearings, right? Where like you could have one bearing here and one bearing here, which gives you like the most stability because you have like the longest like reach. So it's definitely the most stable, but I think it's the most difficult to implement. Because then really like you need like a lot of space around the bed and Y, so it just makes the machine deeper. Because this one you cannot really make more compact. Like there's no like you can maybe shave off like a couple millimeters, like 2, 3, 4. But this is like how it is. So if you want to move the rods around it, you lose that pocket here, right? Like the pocket at the end over the motors, you lose this pocket. You don't have the pocket on front. So by having the rod here behind me, I can make use of this space that I have either way, right? Because I have to place the motor somewhere. Mm. So yeah, let's see. I think most likely we'll just have to like widen if we want to make use of the full bed. I think for me personally, it's fine. Like if you don't reach the outer 5 millimeters of the bed, because it's always like a bit useless to be honest. Because like if you print too close to the edge, like it starts curling up, lifting the edges of the bed. So yeah, I don't know. For me, it's fine. And I think like it's an interesting idea to just have two bearings here. What I might do is actually I might modify the bearing to accept two. We print one and just see how it changes. Like I'm not going to print them both. I just like modify, print one, and then we try one side with two. Then you can just see like when you wiggle this, like how do the two sides behave differently with one and two bearings. But yeah, that's for next time. I'm quite busy at the moment. Yeah, just mentioned like I'm moving to a new place soon. Lots of stuff to prepare and pack and select and stuff. So it keeps me quite busy at the moment. Um, so yeah, I think that seems like a reasonable small modification. I can do that and I can print the parts and we can see how it works. But next week we most likely will work on the switch wire. The switch wire will get a 48-volt um, support for yeah, basically all steppers. That's where the 5160s come in. So that's one project I want to tackle. And also for the V0, I have like a couple of things like lined up, like lightweight X-axis. The canvas tool head board we still have to do for the V0. So there's also like a bit of work. So also we'll do ender wire, this machine, V0, this machine, just like rotate it a bit because it gives me more time to work on the files for this machine. It's always if I do streams, like this is the most work intensive I can do because I always have to like do fusion work during the week. I have to like iterate a bit on the parts usually. So this needs the most time from me to prepare, and the other ones are a bit easier. So most likely the next couple of weeks we will work more on those, more or less till the end of the year, and then next year I have more time. We can work on this. um. So yeah, It doesn't look that bad to me. The plain Y isn't the biggest. Uh, the plain Y is the biggest problem. Yeah, definitely. Like this is for me like the number one thing to tackle. And then we can see how this like changes the overall behavior. I mean, like the things like the stacking itself isn't too shabby. It's just like this weird pattern. Yeah, but yeah, would be very fun if it would work perfectly off the bat, right? Like the fixing is actually like the cool part. Cool. Yeah. Thanks everyone for tuning in. It was quite a busy stream actually again, which was nice to see. So see you next week. Enjoy your weekend. Bye.